So going back, class, we said that the data that we're using is wage. So I show this class. This is your dependent variable, and these are your independent variables, the 7 other variables, 3 of which are categorical, and the other 4 are numeric. And we said that the assumptions of classical linear regression dictate that there should be a strong correlation or strong linear relationship between your dependent variable and your independent variable. But we don't want the independent variables to be collinear because it might lead to multicollinearity. Okay. In fact, if 2 variables, independent variables, are functions of each other, they're perfectly collinear. Let's say y is equal to gender and civil status. If education is this value and experience is 2 times education, then that's perfect collinearity because your experience can be derived from education. Just by multiplying education by 2, you get experience. So that's what we call perfect collinearity. And that will create problems because you will have what we call multicollinearity. In particular, if it's perfectly collinear, you'll have what we call dummy variable trap, because it's as if you're just using 1 variable, but yet you're using 2 variables, but they're just actually 1 variable. Okay, so that can be easily seen class through a plot, and we did that using from the site package we have pairs.panels, and from the GG Ally we have GG pairs. Okay, and we learned that best way to do this is to remove all your categorical variables and just create your correlation plot for your quantitative variables, of course, including your dependent variable. And we said here that if we were to use just one for our simple linear regression, one predictor for our to describe our dependent variable, hourly wage, then take a look here. Hourly wage, its correlation with education is the highest. Okay, and it's statistically significant at 0.1%. But by the 3 stars there, the value of the correlation is 0.4. Then the best choice will be education, and that's what we did, class. What we did was to create a simple linear regression where here we're creating the object mod 1 using the LM function. This is linear model. And the way to do it is you define your dependent variable, hourly wage, and then tilde education. And then notice, class, that we're not identifying wage here, wage, dollar, hourly wage, because it's defined here. Data is equal to wage. Okay. Then we run that class, and we said that mod 1 is actually a list. Okay. Mod 1 is a list, and it contains 12 objects. And if we get the names of that list here, it will contain coefficients, rank, QR, call, residuals, etc. We can actually get, for example, if you want to get residuals, and this is coming from your mod 1, you can just use the dollar sign, mod 1, dollar, coefficient. So for example, that's your coefficients. So we were able to get our model class, and our model is what we're predicting is hourly wage. It's equal to beta null plus beta 1 times x, where x is your education. So the equation is hourly wage is equal to negative 0.9 plus 0.54 times education, right? And using that class, we can take a look at our data set. Okay, how many predictions can we make, class? If we know the equation already, how many predictions can we have, will we have? I hope I get a quick answer here. How many predictions, class, can we have? Yeah, thank you, Gab. Why 526, Gab?
Sir, kasi it's the number of units within the data set po.
Number of our sample size, number
Units.
of units or number of responses that
Entries
we
po.
have. Yeah,
Yes, sir.
or rows, no, or number of entries that we have. That's our sample size, 526, and you can see it here in the wage printout here, class 526. Okay, so let me just clarify that. Kasi di ba may equation na tayo, di ba? So let me write that. Our equation is hourly wage, right? Hat. This is your y predicted is equal to negative 0.9. Okay, this is our intercept. This is our beta null plus beta 1. Oh, sorry, that's 0.54. This is our slope beta 1 times your x. What's your x? Your independent variable, education. Okay, so for example, hourly wage 1. So this is observation number 1 is equal to negative 0.9 plus 0.54 times what's the education of educ sub I? So that's educ sub 1, which is 11. So times 11. Okay, therefore we can compute for the predicted value, y sub I here. You'll have a predicted value here, right? You can compute for the predicted value. And if we know the predicted value, class, and we said that there will be 526 predicted values because all of these observations will have their own values of education, class. Okay. How many residuals will we get? How many e-values will we get, class? How many e-values? Okay. Ano ba to? Yeah? How do I get this back? Okay, close ko na muna. X ko na muna. So how many predicted values do we have, class? Since we'll have, oops, y sub I here, predicted, we'll have 526 of this. Therefore, we'll also have e sub I. Okay, we'll also have 526 e sub I because we now get the difference between your actual value minus your predicted value. Okay, so this is your residual. All right, I hope that's clear, class. No? Okay, so let me go back to our all right. Then we learned how to make use of this very important function, the summary function. Okay, summary function here. And let's spend some time looking at this one. So the summary function, class, okay, tells us, number one, what formula did we use? Right? Ito, di ba? So it's calling out the formula that we use. LM, hourly wage regression education, our data is equal to wage. Okay, then we have some statistics about our residuals. We're going to look at this later on when we do diagnostics. And then this one, class, we know this. Huh? We have the coefficients. Okay, we have the intercept. This is your beta naught or beta null. This is your beta null. And this is your slope, beta 1. Okay, and we know the values. We got this from the regression line. And we looked at the meaning of this. It means that for every 1 year increase in education, because the dimension of education is in years, So every 1 year increase in education will lead to our dependent variable is hourly wage, which is in dollars. It will result into a 0.54 increase in hourly wage, ceteris paribus. Okay, and then intercept is the value of your hourly wage when all your predictors are 0. So y hat is equal to negative 0.9 plus 0.54, 0.54 times education. Okay, we said that if education is 0, so we replace this with 0, so this cancels out. Therefore, what's left is negative 0.9, which is the intercept. It's the value of your dependent variable when your all your independent variables are all 0. Now, take note that it does not have any physical meaning. Kasi wala naman talagang hourly wage sa negative 0.9. As I said before, yung company ang magbabayad, yung employee ang magbabayad sa company. Kasi negative, di ba? Hourly wage is supposed to be the amount that the company pays the worker. But if it's a negative, let's say 1, i-round off na lang natin, negative 1, then the employee will pay the company. That's absurd, di ba? However, class, even if it's not significant, we still include this one in the equation. We still include the intercept. That cannot be said of the parameters ng slopes. No? Pag ang slope class hindi significant, hindi siya sinasama. We'll discuss the significance in a while. So we have here, class, we have here, by the way, this is called your individual. This is your individual t-test. T-test, why t-test? Because we're using the t-stat in order to determine whether your parameters are significant or not. So since we're talking about t-stat and a p-value, then this is actually what we call inferential stat. If you recall, class, di ba? Meron tayong inferential stat. Pag inferential stat class, mag-i-infer na tayo. And pag inferential class, meron tayong dito, null hypothesis. The null hypothesis here is that B0 is equal to 0. The null hypothesis here, HO, let's call it HO1, this is HO2, BO, B1 pala, is equal to 0. Our beta 1 is your education. Okay, so we'd like to test whether our parameters are significantly different from 0. So we will have to have a inferential or conclusion. So ito, class, so for each of this, meron siyang standard error. We will discuss, hindi natin inabot to, but I'll discuss it in the recording. So standard error, dalawang klase of your intercept. So that's beta null. Also standard error of your beta 1. This can easily be computed using the mod function class. Kung meron pa, standard error of your B2. So each of your predictors will have their standard errors. And then the t-value. How do you get the t-value? Very easy. The formula for the t-value, the t-stat, is equal to your estimate B divided by the standard error. Okay? So if it's the intercept, this is B sub O divided by standard error ng B sub O. Can you kindly, class, if that's the formula, if you get negative 1.321, kindly confirm by texting yes. If you got this value, negative 1.321. So this is the estimate. This is the standard error. The formula for the t is just the estimate divided by the standard error. Are you getting negative 1.321 and 10.167? Waiting for your chat, please. Waiting for your chat. Wala pa? Test, check nyo lang, class. I-divide nyo lang naman di ba? Ito kasi yung formula. Oh. Ano yung formula? Okay? Just follow the instruction, class. Yes, yes, yes. Okay, thank you. So this divided by this gives you this. Yan, negative yan kasi negative tong estimate natin. And this divided by this gives you this. Okay. Now, bakit natin kailangan si t-value para malaman natin kung based on the p-value kung i-reject ba natin to o hindi. Actually, sa t-value pa lang, pwede natin masabi kung i-reject natin yung yung null hypothesis natin. Okay, if you recall from your statistics, no? So meron tayong t distribution dito. It's a bit like the normal distribution. Ang kaiba lang medyo fat tail siya. Okay? So you have this one and you have this one. Okay, meron tayong t-value. Ang t-value natin is negative 1.321. Alright? Ang tanong natin, class, what is the t-critical? Kasi gusto natin ito yung t-stat natin. Ang gusto natin malaman t-critical. Kasi if you recall, class, di ba? Pag yung t-critical natin, if our t-critical is here, for example, it's here, t-critical. Tapos yung t-stat natin andi dito. What does that mean, class? What does that mean? T-stat natin is to the left of the ano. Ano ba tawag natin, class, area na to? What do you call this? This area here to the right or to the left of T critical? What do you call this, class? This is your RR. In your basic stat, it's your, ano tawag natin dyan, class? Dito sa region na to. Ito yung critical natin, tapos the region to the left of T critical, or here, the region to the right of T critical. What do you call this region, class? It's your class. Ano tong region na to? Tanggalin ko muna tong problema ko pag inano ko yung erase. Tanggalin ko muna to, ha. Uy, nawala. Hindi ko na nababalik sa ano. Schedule na lang ako. Okay, class, anong tawag dito? May sumagot na ba? Blank, blank, RR, class. Sure? Anyone? Clue, class, danger zone.
Rejection
Yes.
region po.
Thank you. It's your rejection region. Okay? So, in other words, class, rejection region yan. In other words, class, saan natin, ano yung reject natin? Yung null hypothesis. Pag yung t-value natin, class, is to the right of t-critical, then reject this null hypothesis. If on the other hand, it's to the left of your t-critical, then we fail to reject. Non-rejection region to. Okay? So, ang tanong, class, paano kaya natin makompute yung ano? Yung t-critical natin? Okay, ang kailangan natin, class, yung alpha. Ano ba yung alpha natin? Diba, our alpha is 0.05. Yan usually. Diba? So, kailangan natin, ano ba yung, kailangan natin, class, yung area. Area, class. Since yung mga natin, yung mga values natin, pwede magkaroon ng negative yan, no? Pwede yung slope natin negative. So, ano tayo, class? Two-tailed tayo. Okay? Kasi pwede magkaroon ng negative values yung estimates natin. So, pag negative values yan, yung t-values natin pwede maging negative. Okay, so two-tailed tayo, pwede maging negative yung t, pwede maging positive yung t. Okay? So, class, pag ang level of significance natin is 5%, ilang percent to? Ilang percent to? Sige nga, please. 5% level of significance. Ilang percent to, class? Ilang percent to? Anyone? Konting ano yung class? Konting review lang ng basic stat nyo. What's this, class? Ilang percent to? Ano yung P dito, class? Kasi di ba natutunan natin pag normally distributed or T-distributed class, students T-distribution, ito mga P-values and areas under the curve yan. Okay, and what corresponds to your T-critical here, class? Ilang percent to? So no one? Okay, thank you. Gab, bakit 2.5%, Gab?
So it's what makes up the whole percentage po.
Mix up,
The
okay?
rejection rate.
Ang buong critical region class is 5%, di ba? Ito yun eh. So, tigkalahati
Yes, sir.
sila, 2.5% to. 2.5% to, class. Okay, so anong value ng P dito? P is a percentage. P is 0.025, 2.5%. Okay, so knowing that, class, we can now compute for the T critical. That's very easy in R, no? So sige nga, class, kayo gumawa the function is, class, kasi ang hinahanap natin yung value, yung T critical. So the function will be Q. Kayo na lang gumawa, class, QT. Okay, the Q, the corresponding value of T. Okay, so pakitype na lang sa anywhere there sa console. Ano yung mga parameters dito, class? Can you tell me what are the parameters that are being asked for this? Ang hinahanap natin yung Q, yung value ng T. In this case, ang hinahanap natin T critical. What are the parameters? Can you tell me, class? If you type QT, okay, yes, QT nga, QT. QT yung code, class, QT. Ito, sinulat ko na dito, QT. Okay, if you type that, class, ano yung mga parameters na hinihingi? Hello, class. Hindi ko ma-X kasi ano eh. Ayan, class, yan, no? Yan, okay? So, thank you, Dayan, no? All right, PDF, tingnan nyo P, tapos DF, tapos NPC, Dayan, anong definition daw ng NPC? I don't think we need this, no? And lower tail. Actually, we don't need lower tail also. Pero ilagay na lang natin. Is equal to. This is the default, no? Yung true. And then log, hindi natin kailangan, no? We don't need the log. You know, we don't need the log of the P. So you can include that log that P is equal to false. Or log that P is equal to false. Okay, so ano yung P natin, class? What's our P? Ang hinahanap natin, thank you, Dan, no? Ang hinahanap natin yung value ng T dito. Or kung gusto nyo dito, T. At least one, class. At least one. Kasi symmetrical yan eh. Let's take it here, class. T here. O kung gusto nyo dito, sige. Dito na lang, sige, dito. What's the value of T here? Okay, so yun ang pinapahanap natin sa QT. What's your P, class? Answer? Sinagutan natin kanina yung class. What's your P? Ay, sinulat ko na nga eh. What's the probability class under this curve if this was to be critical? Answer please, answer. Gab, pakisagot ulit. Sinagutan natin. Class, sana, sana, yeah. O, umuulit-ulit tayo class. 2.5% class. 2.5 to, di ba? Ito 2.5, no? Okay, kasi two-tailed tayo eh, class. If this was one-tailed class, iba yun ha, pag one-tailed. Kunyari, positive lang yung mga values natin. Dito lang yun. Tapos dito, ito yung 5% nyo. If it was one-tailed. Pero two-tailed tayo eh. Kasi t-values, t can be negative or both positive in our case. All right, P is equal to 0.025 or 25%. What's the degree of freedom, class? What's the degree of freedom? Diniscuss na natin yan. Degree of freedom is equal to n minus k minus 1, where k is your number of predictors. Ilan sa n, class? How many observations do we have? Ang tagal naman sumagot, class. Okay. No, Adi. Ilang observations? Ilang observations? Balik kayo dito sa wage, class. Ilang rows, class? Ilang number of observations? Sinagot na rin natin kanina yan. Yes, 526. Thank you, Gab. So, ang N natin, 526. Okay? Ilan yung K, class? What's K? What's K, class? What's K?
Number of variables.
Number of predictors, okay? Not variables, ha? Predictors. Kasi marami tayong variables, pero sa mga variables natin, in this case, isa lang ginagamit natin na predictor. So, ilang K natin, class? What's our K? Ilan ba yung predictor natin? Ayan, o. Class, ilan yung K? Andiyan sa equation natin. Ayan, o. How many predictors do we have, class? K is the number of, hindi. One lang, class. One. One lang. Si intercept, class, hindi predictor yan. Sinasama lang sa equation yan. Pero it's not a predictor, class. Okay, so n minus k natin 1, class, no? And then minus 1. Okay? Ito yung sa intercept. That's why we're reducing it by 1 also, because we're also estimating the intercept. And the intercept, class, and estimating the intercept also decreases the degree of freedom. Okay, so on DF natin, class, 526 minus 1 minus 1. That's equal to 524. Andi dito na yan, class. O, ayan. Diba? Nasa baba ng output natin. 524 degrees of freedom. Okay. So, lagay dito 524. Okay. Comma. Okay. Question. Lower that tail. False or true lang yan. Class. False or true. Ano ba pinapahanap natin? Itong T-critical na to o ito? Pick your choice, class. Pareho lang answer dyan, class. Pareho lang. If you choose true, so dito siya magko-compute sa lower tail kasi sabi mo lower tail is equal to true eh. If false, dito siya magko-compute. Sige, try nyo, class. Try nyo pareho, class, kung true or false, tapos what do you get, class? Okay, answer please. What are you getting? What value? Mark, ano yung discovery? Ano yung O? Yung 2? I guess so. No? Okay, what are you getting, class? What are you getting? I-close na sa lower dot tail. Huwag nyo na isama yung ano, log.p. We don't need that. Tagal, ang tagal lang sagot dito. Walang sumagot, class? Wala nag-try nito? Kaya ako nga hindi sinolve kasi gusto ko kayong mag-solve nun. Come on, class. We're running out of time. Marami pa tayong i-discuss. Okay. Gab, thank you. How does it compare, class, with the t-value natin? We're getting a negative 1.96, no? Or 1.96 positive. Let's use the negative 1.96 to compare with this one. Okay. Negative 1.321, negative 1.96, no? I-delete ko na to. Okay, so ito yung t-value na, ito yung t-stat natin. Sorry for the drawing. Okay, ito yung t-critical natin, negative 1.32. Okay? Ay, sorry, mali. Ano yung t-critical natin? Oops. Gawin na lang ulit. T-critical is negative 1.96. Critical yan, critical. Okay, where is negative 1.32 in relation to negative 1.96? Is it to the right or to the left? Okay, class, paki-chat, right or left? Si negative 1.32. Where is its position in relation to our critical value, negative 1.96? Waiting for the others to respond. Left or right lang yung class yung tinatanong ko. According to Gab, ang T-critical daw is negative 1.96. Okay? O yun ang plinat ko dito, yun ang inano ko. Okay, ang question ko, itong t-value na to, negative 1.32, is it to the right or to the left of negative 1.96? Only two answered, class? Okay, so let me review that. This is our T-critical, negative 1.96. Based on the computation a while ago, our Q sub T computation. Q sub T, where your P is 0.025. Okay, so our t value is negative 1.32. So it's to the right. Okay, our rejection region is this one. Okay, so the value of our t here is in the non-rejection region. Therefore, we fail to reject this. That the b sub o is equal to 0. Okay, lastly, class, we can also, so you can use this, okay, compare t values, or you can use this. Okay, so we compare this with 0.05. If this is less than 0.05, then we reject the null hypothesis. If this is greater than 0.05, then we fail to reject the null hypothesis. Okay, this time, class, to compute for P, we're computing now for P. Okay, I'll let you compute for it, class. Our function will be P. So could you kindly try this, class? P, sorry, it should be PT. We're getting the P value. So kanina, class, QT, this is the value of your T stat. So naman, PT, the probability. PT, class, PT of what? PT, what's the first year one, class? We have your Q. Okay? And then you have your degree of freedom. And then your lower tail again. So could you kindly try to run that class? What is your Q class? .5 yung answer. Medyo iba dito ah. Should be close to 0.187. What's your Q class? Our Q is, we're solving for P. Our Q is, so we have to know the Q. Parang ganito yung class, no? This is our T stat, T distribution. This is negative 1.32. We would like to know the probability, this one. So this is our Q class, this one. Yung negative 1.32 na to. So this is negative 1.32. The degree of freedom is n minus k minus 1, which is your 524. And lower that tail is equal to, this time, because we're here, class, lower tail natin is ano class? So what are you getting? Okay, so Dayan, thank you for your answer, 0.09. Ngayon, 0.09 siya, no? 0.09, pero ba't 0.09 lang? So, tama si Dayan, sabi niya ito, 0.09 to. 0.09% ka. Eh, pero dito, bakit 18%? Bakit kaya, class? So, thank you, Dayan. You're correct, 0.09 based on this, no? Ang Q natin, negative 1.32, DF is 524. Lower the tail natin is equal to true, no? Kasi ang sinosolve natin, itong side na to. Now, why is it 0.187? Dapat maging 0.187 yung answer natin. Dapat yung P natin is 0.187. Because, class, because, thank you, Gab. Thank you, Mark. Okay. Thank you for those who answered, class. Thank you for your participation. Pero bakit 0.187 to? Hindi pa natin nasasagot yun. What do you think is the answer? Why is the probability here 0.187? Okay, the answer, class, is two-tailed tayo, no? So ito 0.09, ito 0.09 din to. Okay, two-tailed yung test natin. Diba? So this is also 0.09. So the formula is actually 2 times whatever your PT is. Pag one-tailed lang sana tayo, then ito 0.09 lang yun. But we're two-tailed. Okay? Two-tailed yung tinetest natin dito. Okay, clear? So it should give us, so if you multiply whatever your answer is by 2, then you get 0.187. Okay, thank you. All right. So hindi ko na, ito class, subukan nyo lang sagutin ha. It will also give you an answer. All right. So let's keep that for a while. Okay, kasi we need to try to catch up with the other section. But anyway, when I create my yung recording na hindi natin matatapos, I'll give a brief review. No? Okay, so let's go here. Meron pa tayo dito, no? How about this class? Ito alam natin, di ba? Ang 3 stars natin, that means 0.1% yan. 0.1% yung level of significance. Ang ginagamit usually natin 5%. Sorry. Significant yung statistic at the 0.1% level of significance. Ito at the 1% level of significance. Ito at the 5% level of significance. So minimum class dapat maka 1 star tayo. Okay, kasi pag dot lang yung class, significant siya pero 10% na. 10% level of significance. All right. So this one, meron tayo ditong residual standard error. Okay? So, may standard error naman tayo dito, no? Kanina may standard error tayo dun di ba? Ito, may standard error tayo dito ng SSE, standard error ng mga parameters, which are two types, standard error ng slope at saka standard error ng intercept. Intercept at saka slope. Kung marami pang slopes, kunyari multiple regression tayo, then maraming B1, B2, B3, etc. So kung ilan yung predictors, ganun din yung standard errors natin. Nakalinya dito yan, no? Tapos doon din may mga standard errors sila. Okay? Then meron tayo ditong residual standard error. So standard error of your residuals, no? SE sub E. Okay, you have 3.378. So we're going to discuss kung paano na-compute yan. And then ito, class, alam natin to, 524 degrees of freedom. This is now your your n minus k minus 1. Then meron tayo dito na multiple r squared na 16.48 at saka adjusted r squared. So discuss ko lang to, importante sa atin to. So yung multiple r squared natin, it's the proportion of the variance of your dependent variable hourly wage that can be explained by your independent variable education. So ngayon, isa lang kasi ginamit natin na predictor, ito si hourly wage, sabihin natin ito yung variance niya, around 16% lang dyan ang kayang explain ni education. E paano yung yung 83%? Aba, ito yung unexplained variance. Ito yung explained variance, explained by education. Ito yung unexplained variance. Sino mag-explain yan? That's where you can add other variables to try to explain your hourly wage. Okay? So what happens, class, is usually hindi lang nagsisimple linear regression kasi baka mahina yung predictor power ng loan, ng iisa lang na, tsaka maraming phenomena, class, o maraming circumstances sa finance o sa economics na hindi kayang explain ng isang isang variable. So usually marami yan. So maybe ito yung predictor 2, predictor 3, predictor 4. So the higher the number of predictors, the higher will be the R squared. Yan yung tawag dyan. R squared is 16.48. This is also called the coefficient of determination. Ang tawag dyan, coefficient of determination, yung porsyento, the percentage of the variability of our dependent variable, which can be explained by our predictor. So we expect that the more predictors there are, the higher will be your R squared. Is a high R squared good? Yes, but to a certain limit. Kasi class, pwede tayong magdagdag ng let's say 100 variables. No? Nagdagdag tayo ng 100 predictors dito. And so siguro naging 99% na yung yung coefficient of determination yan. Okay, ang question, class, okay, sa econometrics modeling, meron tayong tinatawag na concept ng parsimonious. If you can explain, class, a particular variable using less variables, then so much the better. You know why? Kasi practically, very costly yan. Ibig sabihin, 100, magsa-surveys. You'll conduct survey, field survey, pupunta ka doon sa probinsya, tapos ang dami mong tatanungin, tapos i-ano mo yung data. Mahirap yung class, di ba? So that's why there's what we call an adjusted R squared. Ito yung adjusted R squared. Adjusted R squared. Okay, ano yung adjusted R squared? Adjusted R squared is always less than your less than your R squared. Okay. What happens, class? What happens? Yung adjusted R squared natin, ginagamit yan for multiple linear regression. Okay? So, ganun din, class, yung adjusted R squared. Dagdag yan. Ngayon, 16 point, where's that? 32. Okay? If we add more variables, tataas yan. Yung 16.32 niyan. Until it reaches a point na, kunyari naging 52% na siya. Tapos pag nagdagdag ka ng another variable, magiging ano na to? 51 na lang. O class, so ano nangyari? Si R squared, tataas lagi ng tataas yan. Pero sa adjusted R squared, it reaches a certain point when you add another variable, bababa na siya. Ibig sabihin nun, we are now penalizing our model for including that other variable which did not really improve the model. Okay, so yun, ang gagamitin natin class pag multiple linear regression, ang titingnan natin tong adjusted R squared and not the multiple R squared. Okay, pause muna ako class. Clear ba yun? Clear siya? Yung concept na itong mga to, ano? Okay, good. Good. Kasi ang gusto natin class, gusto natin pag tinignan natin to, confident tayo, alam ko yan. Alam ko yung mga numbers na, alam ko yung, di ba? It gives you confidence and at syempre yung may makakalaban lang tayo sa mga Arneo, no? Hindi lang tayo right? Hindi lang tayo, we don't just compete with the other tayo, lasal tayo di ba? So maganda class yun na intindihan natin and it's good to understand the anatomy of this regression output. Okay, konti pa ito na lang. So meron tayo dito class ito. Ito F stat, saan nanggagaling ito? Tapos merong degree of freedom na 1 at saka 524. Tapos may p-value din. Okay, so yan class, nanggagaling yan sa overall goodness of fit test. Overall goodness of fit test. Okay? And si overall goodness of fit, aka yan, also known as ANOVA test. Analysis of variance test. Okay? So since may p-value tayo dito, may f-stat nga Pero inferential to. Ano yung null hypothesis natin? So I'll just generalize. Ang null hypothesis natin dyan, so overall goodness of fit test, ibig sabihin ng class, beta 1 is equal to beta 2 is equal to beta 3 is equal to that is equal to beta n is equal to 0. So notice hindi ko sinama si beta null. Notice class, tinatest natin yan. Lahat ng mga variables, if they're all one and the same, equal to 0. Okay, yan ang test dyan. And ang distribution na ginagamit dyan class is your F distribution. So it looks like this. Parang ganun sa F, no? Medyo skewed siya. Pag ganyan. Tapos meron tayong, so may F-stat tayo dito, no? May F-stat tayo. Hahanapin din natin yung hahanapin din natin yung F critical, parang kanina, no? So asan kaya si F critical? So is F critical to the left or to the right? So ganun din, pero ito one-tailed lang to class, no? So lower that tail dito is equal to false. Okay, so you know how to conclude class. Depende dun sa, alam na natin kasi yung F-stat pero mako-compute din actually natin to. No? So paano natin class ko-compute yung nito? How do we compute for the, sige mamaya na, yung na muna, no? Ano tong 1 na to? Degree of freedom 1 is equal to your K. This is the number of your predictors. Degree of freedom 2 is your n minus k minus 1. Okay? So your n is 526 minus k, which is 1, minus 1. So 524 to. This is your DF2. Then may p-value sa dito. Okay. So paano natin kaya mako-compute to? Ganun din kanina class, no? So p-value, pero hindi t, kasi kanina pt. Ito ngayon pf. O, di ba ang dali class? pf, no? So again, ano yung p natin dito? P. Okay, sorry. PF tayo, no? So ang hinahanap dito, paki-check nga class. What are the parameters asked kung yung p-value ni f? Ano hinahanap dyan, class? Anyone? Ano ba yung mga parameters? P tapos, P and then, sorry, not P. P nga hinahanap natin. Hinahanap yung F stat. Tapos ano? hinahanap yung sa ano, degree of freedom 1, degree of freedom 2, dalawa. Right? At saka lower that tail. O sige, paki ano yan, class. Is equal to false to, no? Kasi wala tayong lower tail. Dito lang tayo sa right tail lang. Okay, ano yung, ano natin? Ano yung f-stat natin? Ito, given, no? Mako-compute din actually natin yan, no? QF naman ang gagamitin yun. You want to compute, no? Alright, anyway. So PF, f-stat, which is 103.4. Degree of freedom 1 is 1. Degree of freedom 2 is 524. Ano yung lower tail? False. Okay, what value are you getting, class? What value are we getting? Hello, class. Just perform this. PF no din? PF? Ano yung F-stat ang ginamit nyo? Dapat 103.4, no? Ito pala. Okay. Alright. Sorry, hindi ko nakita yung e to the negative 22. Okay, tama. I hope you got the answer of the yan. Now, itong nakalagay dito, class, estimated to. Hindi siya eksakto, no? Kasi ang nakukuha sa talagang computation is 2.7 e to the, I'll explain why this is different, no? Kasi dito 2.2 e to the negative 16. Sa limitation to, sa limitation ng pag-compute. But actually the f-stat is, the p-value is 2.7 e to the negative 22. So ibig sabihin, mas maliit pa, no? A lot less than 0, 0.05. Okay, so we were able to show here the p-value. Ang p-value natin is yun, 2.7 e to the negative 22. Hindi exact yung binigay sa atin dito. So what's our conclusion, class? If we know the p, if we know the p, if we know the p-value, class. Compare this, of course, with 0.05. Sabi natin, when the p is low, the null must go. Low in comparison with 0.05. Okay, the null must go. So, anong conclusion natin, class? This one is our hypothesis. So, beta 1 is equal to beta 2. We reject this. Ngayon, kasi simple regression lang tayo, class. Wala tayong B2, wala tayong B3, B4, walang B7. Ito lang. No? So, we reject the hypothesis that B1 is equal to 0. So, pareho lang kanina sa conclusion natin sa individual t-test. Okay? So, experiment yung nga, class. I-compare nyo si 103.4 sa critical. Paano kaya natin makukuha yung critical F? F critical kaya, class? Siyempre, ang hinanap natin yung F value, then Q, class, Q. QF ang gagamitin nyo. Diba? Parang ganito, no? I'll give you a hint. Ito yung F statistic natin. Okay? Ito yung F critical natin. Ilang percent to, class? Oh, can you tell me? Ilang percent to? One-tailed lang siya, ha? Ito yung F critical natin. One-tailed, therefore, ilang percent yun? Faster, please. Sana mas mabilis yung sagot natin. Ito, class. Hello? Yes. All right, thank you. Correct. Then 5% class. Kasi level of significance natin 5%, no? Kanina nag 2.5 tayo kasi two-tailed class eh. Itong F, one-tailed lang lagi yan, class, ha? Okay, sige. So paki-compute, class, yung ano, F critical. And then how does our F stat? Okay. Compute mo yung F critical, class. Thank you, Mark. Yeah, 5%. So ang formula for F critical is QF, no? So anong hinahanap sa inyo? Yung P, hahanapin yan. Ano yung P nyo? 5%. Diba? So ganun din, DF1, DF2, pareho lang naman. So what are you getting? What's your F critical? Answer, class? Okay, yan. Correct. 3.86, no? So 3.86. Alright, si F critical natin 3.86. Andi dito. Mukhang nabaliktad ako. 3.86 tapos ang F-stat natin 103.4 so dapat to the right siya, no? So rejection. Oh, tama. F-stat natin, si F-stat natin class is where? To the right of F critical or to the left of F critical? Answer? Yeah, you're correct, Adi. You're correct, Mark. To the right. Therefore, pag to the right class, anong conclusion natin? What's our inference? It's in the rejection region. So, we reject the null hypothesis, which is the same lang kanina, no? So, we either base our conclusion on either the F critical and compared with the F stat or the P value compared with 0.05. Okay, sige. So, I hope everything's clear so far. Ito na lang class, no? Clear all drawings and then exit ko to. And then, right, back ako to my mouse. Mag-run tayo dito ng, di ba sabi ko yung overall goodness of fit, ano yan? It's your, ito ko ilalagay. Here class, here. Let's run this time, mag-control, alt-I. So mag-ano tayo, mag-code chunk, and then ANOVA. ANOVA ng mod 1. Ito class, analysis of variance natin. Okay, run. Okay, there you go. Okay, what do we have here? What do we have here? Meron tayo ditong tinatawag na, okay, so may table tayo dito, no? And in this table, what do you see? Andito si F-stat. Andito si p-value. 3 stars. 3 stars. And then we have this one, degree of freedom ng predictor natin education is 1. Degree of freedom na residuals natin, this is your n minus k minus 1. 524. So meron tayo ditong, okay, SS, education. This is your regression, di ba? Ito yung regressor natin. Residual natin, this is your SSE. Okay? Pag sinamap natin to, it will be your SST. Okay, now okay, let me pause there kasi masyado na mahaba. Ano? In the other class, what I did was to explain saan nanggagaling tong SST na to. Okay? Saan nanggagaling SSR? Saan nanggagaling SSE? Let me just explain the concept quickly. No? So yung concept ng SSR, SSE, and SST is very easy kasi ganito lang yan, no? So we have here our, prinat natin si hourly wage at saka si education. Actually, if you recall, ganito yung ano niya, no? Ganito yung dating. Okay, just last 1 minute. Okay, so just the concept behind tapos ano, we'll go. Asan yung plot natin ng ano? This one, di ba? We plotted this last time. Di ba? Ito yung y sub I natin. Ito yung ano natin, ito yung regression line. There's a function in from Broom class. I hope we have already loaded this. Called the augment function. Okay, let's run this. Let's create this object called model1, mod1.receive. You may name it any way you want. Okay, and if you run this class, control enter, then we generate this object called mod1.receive. Okay, there are also 526 observations of 8 variables. but the 8 variables contain different columns. No? Okay, we have here the we have the dependent variable. We have the independent variable. Okay, this is your y hat fitted. This is your epsilon e sub I. This is your error term. Okay, and the others class are values that this is your dv or this is your, of course we know that this is your y sub I, actual or observed. These are values which we're going to discuss when we deal with the diagnostics. Okay, the Cook's distance, as I mentioned before, tells us about the presence of influential points. Okay, what are the 3 important points here as far as data is concerned? Sorry, sorry, I keep on coughing. You have your outliers, you have your leverage, and your influential. Of these 3, the most critical is your influential points, because influential points can affect the values of your B1, B0, and B1. It can affect the value of your parameters. Okay, if it's an influential point, if you change or if you remove that class, it may drastically change the values of your parameters. Now, all influential points are outliers, of course, but not all outliers are influential points. All leverage points are influential points, but not, sorry, all influential points are also leverage, but not all leverage are influential. Okay, so we'll discuss this in greater detail next time. For us now, these are more important. So hourly wage, education, and independent variable natin. Ito yung predicted, ito yung error term. Ito yung sinasabi ko sa inyo, class, 526 all in all. 526 predictors, 526 predicted value, 526 receivables. Okay? Sige. So yan yung ano natin, yung coming from the augment function. Okay? So in this case, tinanggal ko lang class yung ano, no, yung tinanggal ko lang yung hat, yung standard residuals, ang sinama ko lang yung 1 to 4 para makita lang natin yung most important for us at this point in time. All right. So let's quickly plot this class. This one I think I have to share with you. Have I done this class? Sorry, I didn't check the last recording. But if you don't have this, kindly and run that now class, please, and tell me what you see. Now, we're using here ggplot. Okay, make sure that you load first ggplot2. ggplot2, and then that's the only time you can run this. Okay, and then run this. Okay, so if I run this, this is how powerful ggplot2 is. Okay, did you get this class? Did you get this? Kindly chat, please. Any questions so far? All right. So this is your regression line, ba? Ito class. these are our actual points. The red lines here are your residuals. They are the distance between your actual drawing lang ako ng konti. So this is your actual to. Ito yung mga y sub i's natin there. This is your y hat. No? So this is your y sub I. Let's say y1 sub I or y1. This is the corresponding y hat 1. Kunyari ito, pareho sila, no? Kunyari ito y10. So y10, to connect it to your regression line, so y hat 1, may residual din siya. So ito yung residual ni y10, ito yung residual ni y1. And remember, class, sa regression line, ang objective natin is minimize we want that your error squared should be minimized. Minimize siya. So gusto natin, kunyari ito yung, balikan ko dito. So ito yung E1 natin, di ba? This is your E1. Sorry. E sub I na lang to. So dapat yung square niya, ito yung E sub I squared for this particular error term. So bawat isa sa kanila, class, another E squared. So if we sum up all those squares, then then we minimize it, then it will generate now our slope and our intercept. Sorry, yeah, intercept and slope. Yeah, our slope is, if we reduce this, if we extend this, class, this is 0, it's negative, di ba? So tama, negative yung intercept. Diba? So our slope is 0.54. We draw here something. Rise over the run, 0.54. Yung height na to, ito 1 to. So that's the slope class of this model. Okay, so there are some things that we need class to know here. Could you kindly, class, tell me what's the hourly wage, average ang hourly wage, please? Could you kindly compute, class, the average ang hourly wage? Any chat, please? What is the average of the variable hourly wage, our dependent variable? What is its average? Class? It should be very easy, class. Why am I getting why are you taking it so long to answer? So the average class of hourly wage is 5.896. So let's go back to our plot here. So, no? So, annotate ko lang din to. 5.896. Okay, let's assume, class, sabihin natin ito 5. 8.6. Let's assume you decided not to use any predictors. Hindi ka nag-research, no? Meron ka ng data ng hourly wage. Tapos, ang gagawin natin, to predict hourly wage, ay, ano na lang, huwag na tayo gumamit ng regression. Kunin na lang natin yung average niya, which is 5.8916. So, ito. Diba? This is the average wage. No? Assume nyo class na wala pang predictor. Ha? Assume nyo wala pa yung regression line. Okay. So, what do you have here, class? What do you have here? Babalik tayo sa natin, sa question natin. So my question is, if education was 11, what will be the average hourly wage? 5.89 or 5.9 na lang. If education is 15, what will be your predicted na hourly wage? 5.9 pa rin. So no matter what the education class, no matter what the education, ito yung mga value sa education, di ba? Yung y natin, y value will be still 5.3. Okay? So why is that so? Because now we're not using any predictor. We're not using education or any other predictors. Basta, gamitin lang natin si hourly wage, yung average niya. Yun na yun. Okay? Yun na yung ano natin. Yun na yung prediction natin. Right, class? Okay, clear tayo so far, class? Clear tayo so far? Paki-chat naman kung yes or no. Okay. All right. So, if we're going to use that class, yan, yung value na yan, ang tanong, meron bang quote-unquote mga residuals yan? May mga errors ba yan? Will there be, class? If we're just going to use the quote-unquote lazy model of just get the average, huwag na mag-regression ka pa, ba't ka pa mag-charge of FINTSAR? Walang kwenta naman yan, i-average mo na lang yan. Di ba? It makes sense then, di ba, class? Kasi hindi ka nakukuha ng data ng education, hindi ka na magsa-survey. Ba't ka pa magsa-survey? Cost of time lang yan and cost of money. Di ba? Agree, class? Agree? Is that a good point also? Class, practically, is that a good point? Yes or yes, class? Yeah, of course. Yes, thank you. Correct. Yes, di ba? Average sa lang. So, sige, anong years of education mo? 15. Sige, ang average hourly wage mo 5.9. Ikaw, anong years of education mo? 25. 5.9 ka rin. Walang pagkakaiba, class. It doesn't matter kung anong education nyo. Basta, ang average, ang predict natin na hourly wage is 5.9. And of course, you know the weakness of that. No? Okay, not using information will really produce most terrible results. No? So may residuals tayo yan. Ano yung residuals natin? Ito. Yung difference class ng mean natin, sorry yung difference ng mean at saka ng actual point, that's a residual. Ito, residual din yan. Ito, residual. Ito, lahat ng mga yan class, no? Mga residual yan, yung difference between your actual yi minus your y hat, y bar. That's your average class. Kung i-compare natin si actual value y sub I kay y bar, so notice class, wala na ako ilalagay na y dito, no? Na I pala. No I here, class, no. Bakit? Kasi lahat class, lahat dito pare-pareho lang yung average nila. Okay? Alright. Okay, pag kunin natin class yan, okay, and of course, class, what would be, if we sum this up, class, ano yung answer niyan, class? What will be the answer here? Again, paki-chat, class. If we add the difference between the actual value and the mean, what will be the answer, class? If we add everything natin, tapos kunin natin difference sila, tapos add everything. The answer is, class, variance. The answer is, thank you, Glenn, pero hindi siya variance. The answer, class, is 0. Okay? I-add yan, class. Subukan nyo i-add yung mga differences yan. Kasi yung iba, di ba ang average ganito eh. Parang iba-balance yung nasa taas, above the mean, and below the mean. Kung balance yung class, eh di pag in-add natin yung class, 0 yan. Okay? That's why we don't get the sum of that. Just like the regression class, no? So, pag in-add natin to class, ang gagawin natin dyan, I observed value minus the average, and then square natin yung class. May tawag dyan. Ang tawag niyan, sum of the squares total. Yan. Okay? So, sum of the squares total residuals. Yan. Kasi total residuals, kasi wala naman tayong ginamit na predictor. Ang ginamit nating class, yung average lang. Okay, so we call that SST, sum of the squares. So, naintindihan natin to, class, ha? Sum of the squares. Diba? Sum of the squares. Ng total, ano yung total? Difference between your actual and your average. Okay. Yeah, okay, good. Fredericks, thank you for your question. Papunta na tayo doon, no? Papunta na tayo doon. So, tama si Fredericks, bakit hindi tayo mag-regression? Eh, may data na tayong education. Correct, no? So, let's use education. Kasi that will give us a more informed prediction. Okay? So, sige, meron tayong di ba? Meron na tayong education data. So, wag natin gamitin si average, gamitin natin si education. Tapos, nung ginamit nga natin class, ito yung result, no? Ito yung regression line natin. So this is the result of using education. All right? Di ba? This is the result of using education. Okay. So, ano nangyari, class? There was an improvement. Nag-improve yung model natin from yung average naging regression na. Okay? So, may tawag tayo dyan, class. Yung difference ng predicted yi hat. Hat, class, ito di ba? Hat to, lahat na nasa blue hat yan. Minus the mean, ito. Yung difference yan, class. And then, as usual, squared natin yan. Ang tawag natin dyan, sum of the squares of your regression. Yan. Ito yung question kanina ni Frederick. Hindi natin gamitin yung regression. Okay, good. So, gamitin natin, no? Tama. Kasi may data na tayo, eh. We have the data for education, then let's use it. So now, we're comparing yung base predictor natin, which is just the average, and the regression line. Okay? So yung difference nila, pag square natin, ang tawag natin dyan, sum of the squares of your regression. Okay, then we have one last, no? Okay, perfect ba yung natin? Perfect yung model natin? Lahat ba ng actual data points nasa regression line? Answer, no. No, class. Ibig sabihin, may mga errors pa rin tayo. Yung errors na nanggagaling sa deviation natin ngayon from the regression line. Hindi kasi perfect yung model natin. Hindi niya correctly na pre-predict lahat. Yung ibang points below the blue line, yung ibang points above the blue line. So once again, class, if we get now the difference between your y, okay, ano to? Your actual y sub I minus yung predicted natin y hat sub I. Okay, kino-compare natin, class, yung actual, no? at saka yung predicted natin nasa blue line. Yan. Yung difference sa class, pag inad natin lahat yan, 0 yan. So we don't add them, no? We get the square of that. Okay? And when we get the summation of the deviations, of the differences between your actual data point and your predicted value, ang tawag natin dyan, no? SSE, no? Or sum of the squares of your errors. Yung errors natin is the difference between, tama, di ba? Y sub I, yung actual, minus, this is Y sub, Y sub I minus, sorry, Y hat sub I. Sorry class, medyo, ang gulo na ng writing ko. Okay, let me pause for a while, class. Let me pause for a while and, malapit na mag-time, no? Wow, time flies so fast. Let me pause for a while and ask you, class, if nakukuha mo so far. Honest, class, ha? Honest, Okay, my question dito, before you answer. Queen, once again, please share your question to everybody so that everybody can learn from your question. Sabi ko nga sa inyo, class, your questions are very important. No? And always, class, make it a practice to share your, don't be ashamed, class. We never treat questions here as no dumb questions here. Pina, please, paki-share. Okay, sabi ni Quina, what's the difference of the sum of the squares and the least squares line? Okay, yung sum of the squares, itong formula na to, ito. Ang least squares line, yung equation natin, y is equal to, y hat is equal to beta null plus beta 1 times x. Yan, ito yung least squares line natin. Yung regression line natin, intercept, slope, equation siya, class, equation. Di ba this is the equation of the line? Least squares line, class, is a line. So it's represented by a line equation. Sum of the squares is a formula. Where we're getting the difference, squaring it, and then getting the sum. Okay, Quina, did that answer your question?
Yes, sir. Thank you po.
Okay, any more questions, class? Okay, feedback, please. Please, kung yes, so far, kung naiintindihan yung tatlong yon, class. We'll go to that, Russell. Where is SSR? But good question. Where is SSR applied? Okay. We'll go to that now. Naiintindihan ba, class, yung so far, yung SSR, SST, SST total, no? Sum of the squares total, which is just the difference between your mean and your actual data point. Squared mo yan. Yan ang base natin, no? Base model natin. Wala tayong ginamit na independent variable. We just use the dependent variable, yung average niya. Okay? So wala pang feedback, class, kung naiintindihan yung SST, SSR, SST. Waiting for your yes or no, class. You can answer no, class. No problem about that. Yes or no so far? SSE, okay. Y hat, your predicted value. Y hat is your predicted value. Yung nakuha natin sa, yung regression line yun. Yung points dito sa regression line, lahat yan Y hat yan. Okay, SSE again. Okay, sige. Okay, tatlong to, class, mga tatlong sets of points to. Number one, yung actual natin, itong Y sub I natin. Yung mga dot na yan, lahat yung mga Y sub I. Actual. Tapos ito, class, ito. Y bar. Average. Tapos ito naman blue line natin, yan yung Y hat natin. Okay? So tatlong klaseng Y dito, no? Itong Y sub I, yung actual, yung mga black dots na yan, itong orange dito, itong orange yan, yung line na yan, which is your Y bar, which is 5.896, and then your Y hat, itong mga points dito na nasa regression line. So, tatlo. Okay. So, I hope you got SST. Si SST class, tingnan nyo na yung formula class and you won't get lost here. You're just comparing ano ba yung Y sabay. Ito, Y sabay ito. No? Ano yung Y bar? Ito yung Y bar. Ang corresponding Y bar niya, ito eh. Itong orange ito, which is just 5.896. Yung line na yun, di ba? Ito, Y is equal to 5.896. Yung line na yun. Y bar. Itong line na yan. Okay, so if this is, let's say, 20 something minus 5.896, yun plus yung deviation. That's your Y sub I minus Y bar. And then square mo siya. Tapos gawin mo rin for the others, no? And then get the summation of that, you get SSE, sum of the squares total. Okay, next. Ano naman yung sum of the squares regression? O andito naman gagamitin natin si regression line natin. So magkakaroon ngayon ng difference between actually improvement, no? Because of regression class, okay, nag-improve. Instead of just using the mean, ito na naging line natin instead of just this horizontal line. So yung difference sila class, difference between your mean and your y hat, difference between your class, no? Difference between your y hat, ito, and your y mean class is your regression. Yun yung improvement sa model natin. Instead of just using the average, ang ginamit natin si regression line. Okay, magkaiba yan. So magkakaroon tayo ng deviations yan. Quote-unquote errors, no? Tapos square natin sila. Tapos isum up natin. So ito yon. Y hat minus Y bar. Okay? Okay. Lastly, kaya ang i-compare naman natin, ito alam nyo to eh, kasi alam natin yung Y sub I. Tapos alam natin yung Y hat. Diba? Ang tawag siyang class residual or errors, diba? Kasi mali yung prediction natin. Ang value dito, 25 kunyari. Ang prediction natin, ano lang, 4 point something. Eh di mali yan, class. Eh di residual yan, error term yan. Kung i-minus mo, class, yung actual minus the predicted, ito nasa blue line, ito, class, ito. Ito. Ito, at saka ito yung predicted natin, ito, yung nasa blue line, ito yung class. Yan. Itong height na yan, residual yan. Error yan. Kasi mali yung pag-predict natin eh, versus the observed value. So pag kinuha nyo, class, yung difference yan, anong difference? Actual minus predicted. Diba? Huwag mo isa-sum up kagad. Square natin muna, tapos kunin natin yung, saka natin i-add. Ang tawag yan, sum of the squares, errors. Okay? Sum of the squares, errors, a lot time na. Okay, did you get that, class? Get that? Okay. Konting minutes lang, class. Just 1 or 2 minutes. Tapusin ko lang to. Okay. Okay, so if you can see here, class, okay, pakiran niyo muna to. Para pakiran niyo tong ANOVA, class. ANOVA ng mod 1. And tell me what you see. But we'll explain that next time. Ito lang muna. Okay. Then, kinaya to, class. Kulang ako dito. Yeah. So, okay. Okay, dugtong lang kasyong carrot to. Okay. So, ang tanong ko sa inyo, class, what is the value of SST? We'll end in this. No? What is the value of the sum of the squares of your error terms? Ang dali niya, class. No? Kasi kukunin lang natin, class, una, what are your y sub I? Ano yung y sub I natin? And one, class, what's our y sub I? Yan yung actual values, okay? Which is, di ba, wage yan? I-attach natin si wage, class. Attach natin si wage para hindi natin uulitin yung wage na, no? So that's your y sub I natin is hourly wage, right? So hourly wage, will this run? Yes, class, kasi naka-attach si wage. Minus the mean of hourly wage. Diba? So hourly wage minus the mean of hourly wage. And then we square this. And then we get the sum. Tingnan nyo, class, yung formula. Una, hourly wage minus average ng hourly wage. Then i-close natin kasi i-square natin siya and then just get the sum. Right? So, if I run this, yeah, so the sum of the squares of the total is 7160.414. Okay? So let me end there, class.